everyone, and I will cover, yes, the pulp and paper use case, but as I saw a bunch of other use cases used, I'll take the 10 minutes and try and expand a little bit to give more food for thought on other use cases perhaps. But first, maybe just one slide on who Maya is and who I represent. So we're a Canadian-based company, and we develop software and solutions for manufacturing engineers and other process engineering solutions. We've been in business for 40 years, and we have about 20 or so software modules and 20 or so services solutions, mostly in the digital transformation domain, which is what I will focus today on the right-hand side here of today's topic. But we cover from the conceptual design all the way to the product manufacturing to the use and operation. So that's really the life cycle of those products. And why maybe perhaps we were brought to the table. When we look at AI and IoT, we have 4.5 million connected IoT sensors that we've deployed in different manufacturing and other industrial environments, with about 120, we're now at 150 plus projects and success stories in that domain of digital transformation. Very focused in really the engineering, manufacturing, and operations use case, and that's what's going to be the focus of today's discussion, and hopefully future discussions with all of you as we proceed. When I looked at the use cases, and I'll dive into the specific ones of the pulp and paper client we discussed with, and by the way, the client is Glatfelter, and they'll be presenting next week at Pi World if you want more details on a deeper dive on their process and their use case for AI and using machine learning to improve their production. And data quality as well, and all the change management discussion topics that we've heard today. They're all covered in that presentation. But when I look at use cases in industrial environments, really there's three big areas of the return on investment. You look at either increasing your revenue, reducing some of your cost, or minimizing the risks in your operations. And sincerely, the focus initially, naturally, people would look at cost reduction. But in the end, when we look at the actual use case and the benefits that companies are actually achieving on day one, it's more on the additional revenue side that we see, like increased productivity and improvement in quality that leads to more revenue generating on the operation and industrial floor. So we've focused on the green side of the equation at Maya. And when we look at many use cases and we meet with clients in industrial environment, we make a little roadmap with them on their digital transformation journey and look at each of their use cases, the real business issues they have today, and map the business value to the time to implement and kind of map out where they should kind of start, right, their journey. A lot of people have started in their journey, but sometimes they start with things that maybe are too grand and too far out to achieve in a shorter time and get revenue and get people and stakeholders engaged in the process. So we've tried to kind of map that out. We have a nice AI project canvas, so that's more covering the whole governance of the digital transformation journey, and we can go into deeper dives. But today, really, I'm here for examples from one specific, and I'll show you a few others. So in continuous manufacturing, so Glatfelter here in paper, pulp and paper, they had two major kind of business challenges that they wanted to address first. One was to increase the product quality. And when we think of technical papers, they have a lot of different quality parameters, and some that can conflict with each other on the process side. And so from a paper product quality perspective, they were tracking more than 20 different quality parameters in real time. And they wanted to essentially modify the process and nudge the process to improve those quality parameters. And so what we had to essentially harness is those 600 plus sensors along the food chain. So from the pulp and components that are being fed in, resin and other chemicals and different things, and throughout the whole kind of food chain, if you will, of the paper production cycle. There are many stages on the cycle, and each stages were essentially incrementally adding to or removing from the quality of the end product. And so from this case, it's actually a case of a very complex case to harness. When you look at a discrete manufacturing segment, which we've tackled as well, I'll show you some examples, but in the end, if you look at one machine or one step in that continuous manufacturing process, people have optimized typically for one machine or one process element. The challenge they're facing now is to harness the data from end to end. So from, in their case, 600 different sensors. And at that point, this is where the change management comes into play, because people are used to a few buttons that they can turn on the machines that they're facing, but they're not used to changing many parameters at once over, you know, an entire production line. So there's a lot of change management and feedback loops that are needed to provide the information to either the right system or the right person. There's some controls that are in the loop, but there's some human beings also in the loop. So you need to leverage them and augment them in the process. That's what we were able to do. So in their case, they have a few subject matter experts, like older people that have been, you know, in this industry for a very long time. And they knew inside out, you know, by instinct, what the black box magic trick was to, you know, improve those quality parameters. So that was very important to figure out early on in the process and involve these subject matter experts that knew instinctively what the process, incremental process and improvement should be and could be. But then they actually were augmented and figured out that there are some cases where their instincts were a little bit wrong, but because everybody coordinated in different ways along the food chain, along the production line in different ways, they actually counterbalanced each other in positive ways, of course, but in the end, it was not the optimal situation for the production line. So this is where we increase their productivity over time. And if you want more details, certainly contact me, but I can cover a few more cases here. One was a lithium battery manufacturer where we, again, improved the quality variance. So at the end of the production line with 10 stages in manufacturing, they saved $400,000 in pure raw material. The lithium costs are pretty expensive, and it's very difficult for the environment. You can't easily recycle lithium if something needs to be, you know, a component needs to be wasted because the quality metrics are not met. But it did happen quite often, so, you know, or more often than they would like. So we essentially string, in their case, they had 16,000 real-time telemetry points on these 10 different stages of manufacturing. There were discrete manufacturing stages, so it was a little bit easier to tackle than the continuous manufacturing. But anyway, we can get into that as well. But in the case, the production rate was reduced significantly to reduce the material waste and the lithium that was needed to be recycled, which was a great environmental benefit. Another one, which is more on the big data usage. So eBay has, we've developed a digital twin and a cockpit view of their data centers to look at the cooling aspects and the balance between the IT needs and the cooling, you know, used. And maybe, as I think was mentioned before, the IT departments are starting to wake up to the fact that they're using a tremendous amount of energy in their data centers or otherwise, and being efficient at using it is actually has a big impact. We went from about 2% of the worldwide usage of energy to 4% in just a few years. So it's on an exponential incline rate in terms of the energy usage. So there will be more and more use cases here on the energy savings at eBay. Another one was the CSL, so more of a fleet digitalization in this case. CSL has those self-unloaders, they call it. So it's kind of a mini floating factory that collects dried material. And in their case, it was, again, from an environmental perspective, becoming more energy efficient with their engines, with their, you know, all the equipment on board for self-unloading and loading these gigantic amount of dry bulk cargo that they are moving around the planet. And so we've instrumented the entire fleet with their system, and they gain quite a bit. So in terms of the value and the use cases, you can see some of them here. The main one that I spoke about today in the batch manufacturing, where the improvements in productivity was significant, from 70% starting point to an 80% OEE. That's a pretty significant amount, and the time between failure that went quite drastically changed from 6 stoppages per hour to 2 stoppages per hour. So those are significant amount of wasted material and other things. So lessons learned, maybe a few that were mentioned before. People assume that their data is clean. And what we kind of use as a motto is, no, assume your data is dirty until proven clean, and reliably so, using data pipelines, so that you don't put garbage in and garbage out into your nice machine learning models. And so everyone that you ask, subject matter expert, they'll say, yeah, my data is very clean. But why do we see in the traces that the data is not clean? It's not because they're lying. It's because in the end, the subject matter expert are biased. They have lived through and looked at the data and the profiles, and they translate in their head if it's between Fahrenheit or Celsius, or if it's whatever mistake that's in the system, they've kind of used to kind of get over it. And I always use this analogy. I couldn't believe that I could actually understand what I was reading. If you read this paragraph here, any English speaker will be able to read this, but it's completely mangled, right? But that's the way that subject matter expert in an industrial environment act, and they don't realize it. So that's why when we look at those data profiles, those are totally normal, but they need to be assumed, dirty until proven clean, reliably so, with data pipelines that we have and technologies that we can bring to bear. Change management was talked about a lot, so I'm not going to go into it a lot, but one of the tips that I have for people is, one, of course, leverage those subject matter experts early and stakeholders early in the process, so they understand that they will be augmented by these new technologies and the digitalization process, but also use and leverage their existing tools. So if they're looking at a certain display or a certain dashboard, simply add the AI results or the ML results or the tips and tricks into those existing displays. That will make a huge difference in adoption and will fast track the digital transformation. So that's what we've learned at Guyfelter and other places. So again, start with the business challenge and then go from there. Don't do the reverse, don't apply tech for tech's sake. I think that most people have learned that's not a good thing to do. But we still re-emphasize it because a lot of people say, just bring AI onto my industrial food chain and use that magic wand to solve my problem. And then when you say, well, what are your problems? And then they're like, well, we'll apply AI to whatever it is, but that's not the way to go. So that was it for me. I just wanted to give you a quick glimpse, and we can go into a deeper dive as needed later.